but this looks like a continuation, huh? Well, welcome back. This is me, Totality Hayo. Today I thought of teaching something here. So why not? Let's start teaching. Do I have the marker? Let's check. Let's start with a topic known as growth rates. What is it? The topic name is called as growth rates. Okay, let's understand. So, what I'm gonna do is write down the topic growth rates. Is it inverted? Let's find it out. Uh-oh, is it? Yep, this is inverted. Can we invert the camera? Let's just check. This is mirrored, guys. I don't know whether I can show this up, but let's understand this, okay? Now, growth rates. Now, growth rates. What exactly growth rates are? Let's understand them one by one, okay? So, growth rates are basically the increased growth per unit time. Unit time by the means of one. Hi Jojo, how are you doing? Hi. Yo, how are you doing? This is me, Totality. How are you doing, Jojo? Nice to meet you. And by the way, congrats for hitting 20 subs. I saw your post. I saw that post. Anyways, let's start. I will respond to your message whenever you start. So, what exactly is growth rates? So, growth rates is basically a topic, okay, where we understand that a plant has, a specific amount of growth. Also, congrats for hitting 20 subscribers, by the way. I saw your post. So, let's start off with something very interesting to know. Okay, we're gonna go to pinpoint structure and understand them one by one. All right. So, growth rates are basically the increased growth per unit time. This unit time can be expressed as 1 second, 1 minute, 1 hour, 1 day, 1 month, 1 year, etc. etc. And main kind of most prominent one is 1 hour or 1 day, where you express that the growth rate can take place in 1 hour or 1 day. Yes, 1 hour or 1 day. Now, growth rates can be varied in an organism or a part of an organism. In an organism, by the means of it could be any cellular organism, unicellular organism, or a part of organism like plants having their roots as following arithmetic growth rate, and the other one, your stem, following the geometric growth rate. We're coming to this topic now. Okay, we are getting to know that there are variety of things we should know more about them. Very interesting, very fun, and nice. Okay, so what exactly growth rates can be talking about? What are we exactly discussing? Huh? Okay, so growth rates. What are growth rates exactly? What exactly growth rates can be done in arithmetic growth rate, and the other one, that is your geometric growth rate. Um, oopsies, my bad. Your geometric growth rate. Let's understand them one by one. Now, arithmetic growth rates are basically what we can say is that one cell of a meristematic cell divides into two of these cells. Now, these two cells will be of, one cell here. This one cell will divide into two cells. Okay, these two cells, one here is meristematic. The other one you see is meristematic, and this is a permanent cell here. Okay, you can see that it's permanent. Oh, my bad, that looks very cringe. Yep, it is looking cringe, my bad. So, one is meristematic, the other one here is a meristematic, and the other one is permanent. Explain, boy. Okay, I'm gonna explain. Okay, so meristematic is, first of all, my bad, goofy up. So, Meristematic cells. What exactly meristematic cell is explaining here? Meristematic cells are basically those cells which have the capability of continuously dividing. Hi Putanayako Mamu Duri Yalama 666. That's a very pretty long name, boy. Thank you for thank you for commenting. Really love you, man. Thank you. Want me to shut up? Oh. That's a very pretty moment whenever I speak up. Hi Vic Edits 547. Hi Trinan. I don't know what language are you speaking. Is this Bengali? I'm not sure. Or Nepali. I'm not sure, man. I don't know. I don't know. But yeah, let's move on. Meristematic cells. These meristematic cells have the tendency to divide again here. I take a tissue. I then divide. Let's say that this tissue is dividing. Now there are two cells. There are two tissues that divide. Which class are you in? I'm in 11th class. I'm class 11th. Hi, Jason Coleman. Hi. How are you guys doing? How are you guys doing? Today we are actually going through this. That's what exactly is going on here. One cell is dividing into the other cell and the other one. Are you Indian? Yes, I am an Indian. But I don't live in India. That's the difference. Okay, I'm an Indian, but I don't live in India. Oh, so you live in this country? I don't know the name of the country, but if you can elaborate it, I would be really keen to know about it. I might be curious, you know? I might be curious. Oh, okay, let's go. Let's move on. So, first of all, so in order to understand this growth rate about one meristematic and one permanent cell, what we're going to do is we will see that one meristematic cell will be dividing into, no, I don't live in that country. Meristematic will be divided into one as permanent and the other as meristematic here. So what else is happening here is that this meristematic cell will divide again, forming another meristematic cell, and the other one here as permanent cell. Now this permanent cell will come back here because the permanent cell has the ability, it has lost its ability. It has lost the ability to divide. You know, as you have seen, this is, suppose this is a cell. After cell division, it will be in two types. That's what I mean here. So, but your permanent cell has loses the ability to divide, and therefore it differentiates. So now this one here is because it may be due to limited nutrient supply, or it could be for many variety of reasons, or the plant has become more older or matured. Many reasons are there, and this process is known as differentiation. If you don't know, it has lost its ability to divide because of the process known as differentiation, by the way. And this differentiation process, you see, is a very interesting process where what exactly happens is that each cell that is there loses the ability to divide, and that is known as permanent cell. It is known as a permanent cell. It does not divide. And if you look at this, it moves on again and again. Here the meristematic cell will divide into two. Okay, I think that marker isn't showing that nicely, but here this is going to be a permanent. Here this one is meristematic, this one is permanent. These two cells will come down here back. That is permanent and permanent. This looks, sorry for my diagram, it looks crash, but trust me, that's how I do it. That's how my method is, by the way. So yeah. So in order to understand this, what we're going to do is we can look at this. This here is a meristematic cell. This divides into one meristematic cell and one permanent cell. Now this meristematic cell is divided into meristematic and permanent cell, and this permanent cell come back here and comes down. Yo, Robert W. Hi, how are you doing, my guy? This is me, Totality. How are you doing, Robert W? That is so unexpected looking at Robert W at this time. You wanna join into the live? If you want, I will end this live stream and we'll do live together. Yeah, I know. I saw the chats. I said no, I'm not from Pakistan. They said, "Are you Indian?" I'm typically Indian, but then I don't live in, India. That's what I've said. The most weirdest part is that the fact they said Indian, but at the same time they're saying like, "I do live in Pakistan." Wow. You're and alright. I did not understand what you're trying to say, Robert W. Do not understand. But yeah, mathematic permanent cell. Now let's see what I'm. Oh. Non-resident Indian is short. True. True. Yeah. Now, actually, I did not have any idea based on that. Wow. I did not have any idea. But let's move on to growth rates. Okay, growth rates. So this one mathematic cell is. Oh shoot, what is this? Alkioha. Hi guys. Hi Alkioha. No man, what the hell is this? Oh shoot. Hi Alkioha. This is a very cringe moment. These people come in this kind of stuff, and I feel very weird in this. Oh, this message is helpful review. Review message. I know. I can understand this. Oh shoot. Oh shoot. Oh, YouTube saw that, guys. Next time I should block that word. Oh shoot. Ow. No, I forgot this is also kind of a swearing word. Oh yeah. Oh, and he's spamming, man. Man, I love you, Elkioha. Oh shoot. Oh my god. Oh. Man, what the hell is that? Oh shoot. Bro violated me by calling me GAY. Nah, bro, how am I? How am I GAY? Like, dude, what the hell? See, I love you, my guy. Oh, now I see the fact that I said you, I love you. Oh, bro, stop being racist now. Come on. God, stop being racist, man. I support you. I do not hate you at all. Even though if you're being a hater of mine, I do not hate you. I love each of my haters and lovers. Okay, so remember that. Okay. So yeah, full bro. But that is kind of bro. You first called me Jamaican and now you're calling me Pakistani. Oh my. Look at this thing. This is called as box. I cannot hit you because you're my hater. I love my haters, but I can hit myself. Oh. Oh. Wait. Oh shoot. That accidentally revealed my something called. Oh shoot. Bro, I accidentally clicked the wrong button and it accidentally removes and it showed something very sneaky. Man, I cannot hit my hater, so I'll hit myself. I don't know what's there inside. It's very tough. Oh shoot, there's a laptop battery. Oh, I might need that. I might need that for my streaming. My bad. See, there's a laptop battery. Look at this. Oh shoot, this is very, very cranky. Oh shoot. Well, we are not gonna unbox that. Why are you so obsessed with Pakistan? Yeah, Alkio, why are you so obsessed actually? See, I respect every country. I do not hate any country right here, except but yeah, there will be some exceptions for hating a country. This message is held for review. Yeah, man. You know what? Sorry, guys. You're Robert W. I might have to make you a moderator here now. I'm so sorry, Alkioha, but yeah. Because I have to follow the YouTube community and guidelines. I mean, even though if you like swear or something, it might be very harmful to the society. Yeah, like this one. I'm not sure whether you call it as a swear word in your terms, but for me it will be a one type. So yeah, please, uh, please save me. Okay, I'm so sorry, Alkio. I truly respect you. Okay, I do not want to delete your messages, even though I know you're kind of scamming me. Stop saying Pakistan. Yeah, actually, not gonna lie, I gotta say stop saying Pakistan now. Now, I take this cell. Suppose, imagine this is your cell. After cell division, what happens? It forms two cells. Wow! It formed two cells. Oh my god, I did not know that. Oh shoot, yeah, I know, right? Oh, that's a very goofy moment here. Are you Pakistani? Yeah, he's spamming. It's fine. Ardone. What's that? Can you say that correctly? I'm not sure. I have never heard of that thing. Anyways, arithmetic growth rate. Let's say, oh shoot, this marker ain't working. Full Jamaican, Homo, SC, okay. Pakistan, yellow belly. You saw my belly? Did you see my belly? Very, very sus. Okay. Now, I don't know, man. I kind of feel sus about you now. Yeah, I'm a good man. Man, I do not hate anyone. It's fine, Alkio. I love you, man. Don't worry. I don't, I do not show any hate to my haters here. I love them. Yes, I do remember you. I do remember you. I just remember your name, but then, you know, it's been a long time actually, not gonna lie. I think I kind of remember you. But anyways, let's start off. Growth rates. These growth rates are very interesting to me. The first growth rate here is the first one is arithmetic growth rate. We have a graph, suppose. It shows a straight line. That straight line you see. Oh shoot. Okay. That straight line you see here is very, very, utterly weird. Why? ST graph physics, man. Dion, dion, dion. Straight line. Straight line physics graph here. ST graph here is a straight line. That is your thought or a topic that you study in physics. But in biology, what we are thinking about this arithmetic growth rate is that it is also a straight line. But in arithmetic growth rate, what exactly happens is that uniformly our increased growth takes place in equal time, in equal intervals of time, meaning that equal distance is covered in equal intervals of time. Okay, well, thank you very much for the emojis, man. Thank you very much. Support you. Support. Support it. Thank you for the emojis. Thank you for the emojis. I'm supporting you here. Look at this. Supported. Whew. Anyways, yeah, growth rate, arithmetic growth rate, straight line. What about geometric growth rate? Let's talk about geometric growth rate here, okay? Let's say that I need a marker. I need a marker. Yep. Here we go. This is your graph. Okay. Here, this is a graph. There's a graph that is going like this. This is your graph. This is known as sigmoid curve, not sigma. It's sigmoid curve. This sigmoid curve you see is also known as S curve. What is it known as? S curve. Yeah, this sigmoid curve is known as S curve. So what I'm exactly mentioning here is that your sigmoid curve is mainly specifically called as you know, a S curve where the stationary phase, exponential phase or log phase and lag phase, okay, this is your lag phase, this is your exponential phase, and this is your stationary phase. Now first let's understand this. I don't have any plan to show. I don't know how to show a plant, but let's see. Suppose I have a small seed. At time zero, of course, it is in the form of seed. I don't have any seeds though. Oh man, I don't have any seeds here. But let's elaborate them. I do not have any seeds. But let's move on. This one seed you see will be growing into a plant. Of course, that's there. It grows into a plant, forms a whole plant, biome that makes a plant, and this plant is basically grown at this time of called as time t, okay, time t, and this length that we'll record it as, it will be noted as lt, lt, okay. Now lt and l0, they form an equation. Now this equation is given as LT LT. I'm not sure. Guys, is my image inverted? Can you just tell me that? I'm not sure. That's why I'm asking you. This is your graph. LT. So this is your graph, and this is okay. Wait, this is the geometric growth rate graph. Okay, and mm, oh sure. What is this? Uh, 1 minute. Mm-hmm. Okay, let's do that. Yeah, you're there. Okay. Get a shout out by commenting. Okay, I'm gonna give you a shout out just by the comment. I will say your name. Okay. Now this looks very weird, but if you comment, it will be really great. Okay. Now let's start off with this one. This one here. Let's say I have a graph. This graph is given as WT is equal to W naught E raised to RT. That is your formula. WT is equal to W naught into E raised to RT. What is this E? This E is known as Euler's number. Euler's number is given as 2.71828 dot dot dot. 2.71828 dot dot dot. That is your Euler's number. Okay? And Euler's number, if you take it as a base in logarithms, you call it as natural log or a ln. That is known as natural logarithms. So E is also known as the base of the natural logarithms. And if we elaborate it here, you know what, let's elaborate it just to make it more clear and more understandable. So let's say that this is your log E. There is a specific number which we don't know. Let's take the variable as x. Okay, and this is your value RT. This is what it is actually explained. Log to the base of E, then x is equal to RT. Bit of biology mixed with mathematics. That's what I'm doing here. So WT is equal to W naught E raised to RT. That is how you show this curve. And this curve, you see, this is your lag phase. Like, you know how in games you lag so hard, bro. It was like, you know, at 999 PNG ping. And yeah, that's what I would say, that the lag takes place in very high ping, right? Then after this lag, he is growing normally. He's growing rapidly, in fact. That is known as exponential graph now. Exponential phase. This exponential phase, you see, is showing the rapid increase. And then this is the stationary phase. This stationary phase, you see, it's basically indicating that oh yeah, the stationary phase here is basically indicating that, oh yeah, this plant is now old. No, not only old, it is also having limited nutrient supply. Hi JXBRBLX. Should I say that chicks be right back? Alex said hi. Hi. How are you doing? Shout out to JXBR blocks. If you wait a minute, do you mind subscribing to my channel? I'll subscribe to yours. Wait a minute. I'll subscribe to yours. If you, since you commented on my stream, I have to subscribe to your channel. That's what is the main motive. Let me just turn off my phone. You will subscribe to this phone, okay? Since you have commented, I will have enough information for you to record. Okay. Now, log E. That's the thing we have done overall. I think we have completed the growth rates topic. We did, right? Yes, we did. Yep, boy, we did. Also, we just did all 100 videos in 3 months. We did put a lot of videos in 3 months, guys. Like 100 videos in 3 months, which is actually having videos each day with an extra video. That was pretty much great of a like part here. And we have studied a lot. We have maintained a lot of progress. We are not gonna give up. We will continue. Okay, let's subscribe to your channel. Um, I'm subscribing to your channel. Just wait a minute, please. Please, dear, wait for a minute, and I'm gonna subscribe to your channel. What's going on into this, huh? Whoa, chill out, dude. Oh, chill out. Okay, go back. That's fast. That's super fast. That is super fast, huh? What is this? Mm-hmm. All right. Um, what up? Where was I? Oh yeah, I have to subscribe to your channel. My bad. Let's go, switch on and let's look at the channel. And yes, thank you very much for anyone who have subscribed to my channel. 81 subs. Thank you very much. Thank you. Let me subscribe to yours now. If you comment on my channel, I'll just subscribe to your channel. Oh, this looks super weird, man. The thumbnail is so weird. Oh, shoot, the thumbnail is so cringe, man. The thumbnail is cringe. Going to your channel, and here you go. I subscribe to your channel. Is it JXB Roblox? I'm not sure. It could be that name. Okay, if anyone whoever comments your name, I'll give you a shout out. Plus, I'll subscribe to your channel. Okay, that's what I'm doing. Anyways, I think did we complete the topic? Yeah, we did complete the topic. Oh yeah, we did, huh? Through the stream, we had the power to complete the stream. Yes, we did complete the stream. Really did, huh? You really did it. That is great. Um. Oh shoot, there are many messages popping up, but I cannot leak my messages at the same time. You know what? Just look at this, okay? Look at the number of messages. Look at it. Can you look at it? It's basically showing 247 messages. I remember one person having this AIRS 247. I didn't know him. I know that person. He's a YouTuber. He's a really good, hardworking person. So respect to him too. Yes, looks like we have completed our work. Now it's time to study respiration in plants. Very interesting topic. Very nice topic. W topic. Let me just take out my textbook and come back. Here we go. Our bio textbook. See this? Yes, this is our bio textbook. We're gonna study respiration in plants chapter in this part. This will be the a chapter where we'll read this chapter. Then we are gonna complete. Okay, so let's start reading. We are not giving up. Our day 53 challenge, guys. Literally, this is our day 53 of our challenge. Tomorrow will be day 54. Only 7 days left for this challenge, guys. Then we will approach day 55. Then we will approach day 58, day 59, and then day 60. The whole challenge ends after this, day 60. My exam starts on the after day 60. So this is gonna be a very hectic and nice moment. So let's start off. Let's continue. Okay, let's do it. Um, respiration plant. Let's start off with something very good. All the energy required for life processes is obtained by the oxidation of some macromolecules that we call as food. Only green plants and cyanobacteria can prepare their own food, and only green plant and yeah, they trap the light energy through the process, which is known as light reaction. They take this light. This light reaction excites the electron of P7 P680 reaction center. Yeah, my bad. I'm so sorry. I'm so sorry. My life went doomed. My life went blank. But let's continue. Okay. I'll also subscribe to your channel if you comment, That's the thing. I'll also subscribe to your channel. Yeah. We are growing, guys. We are growing. We are not giving up, huh? We're growing. We're doing so much work. We're being productive. Let's go. Let's not give up. All the energy required for life processes is obtained by the oxidation of some macromolecules that we call it as food. Only green plants and cyanobacteria can prepare their own food by the process known as photosynthesis. This photosynthesis, where we see that they trap light energy and convert it into chemical energy, and this is stored in the bonds of carbohydrates actually. Yeah, they are stored in the bonds of carbohydrate, like your glucose, 6 C6H12O6. That is your glucose. That is the sugar that we consume when we consume a carbohydrates in our body. We are actually consuming mainly glucose, C6H12O6. Now, in photosynthesis, we studied a lot of stuff like light reaction, dark reaction. We studied the early experiments done by many scientists, and not only that, the light reaction. We studied that how the electron is excited, and then how the whole cyclic photophosphorylation or non-cyclic photophosphorylation has been done. But in dark reaction, we study something called Calvin cycle. Then we studied C4 cycle. Then at the last we studied about factors affecting the photosynthesis cycle. Now let's start understanding by the process of what exactly is going to happen in our respiration. We get the product as glucose in photosynthesis, but what happens to this glucose in respiration? Our main goal in respiration is to oxidize this glucose and overall get the energy at the end. We need to form and get some energy. But this in this chapter we are going in so much depth that we understand many schemes, many processes. We understand how plants inhale, exhale. We understand how glycolysis takes place, where glucose gets converted into pyruvic acid or pyruvate. Then we understand how this pyruvate or pyruvic acid is then converted into acetylcoenzyme A with the help of something called as oxidative decarboxylation reaction, or known as link reaction. Then we understand citric acid cycle or tricarboxylic acid cycle or TCA cycle or Krebs cycle. Then after this Krebs cycle, we study something called as your ETS, electron transport system. In Krebs cycle, we mainly release carbon dioxide, water, just to get more and more ATP molecules. And that ATP molecules is first fall from NADH plus H plus, then you get it from FADH2, then also from GTP. These three molecules you see can be converted into ATP molecules in the ETS, thus giving us the energy rich molecules now. Now, ATP is very important to know because ATP is the way where we're going to start off. Also, four protons are needed in this ATP to form that ATS. So, yeah, that's how it's done. Let's start off. You're not gonna give up, huh? I gotta drink some water, by the way. We gotta drink some water. Yeah, we gotta drink some water. We should make this speech, huh? Wait a minute. Let's start off, huh? Let's start off. This is the one, okay? So, cellular respiration takes place. What exactly happens in cellular respiration? You see, the oxygen that you get will clearly oxidize with glucose, breaking the carbon-carbon bond, and also this is actually forming energy. Now, this process is very, very small. It's a very small process. Okay. This is a very slow process, and we go through many steps here, like glycolysis. Then we go through Krebs cycle. Before that, we go to oxidative decarbonylation. Then we move into metabolic pathway, where we understand how proteins uh, or or that is amino acids and your lipids, or that is your fatty acids, and are basically used and to convert it into the form of an energy through this process. So this is also one such complex method. And then we study about ETS, electron transport system. That ETS is very important to know too, because not much important because you study about five complexes. The first complex that you study here is basically known as your something called as dehydrogenase. Oh yeah, it's NADH dehydrogenase. Then it is cytochrome BC1. Then you study about cytochrome again. Do, do you? It's no, it's my bad. Succinate dehydrogenase. After that is a complex cytochrome A3. Then you study about the complex fifth complex and fourth complex. That fifth complex is your ATP synthase. Now let's understand this one by one. So, in order to understand what is lipolysis, what we're going to do here is we will take glucose. We'll take glucose C6H12O6, 6 carbon molecule glucose. We will take the glucose, and once we take this, we are going to add one phosphate. That is taking ATP and converting into ADP. That is adenosine diphosphate. Okay, from adenosine triphosphate to adenosine diphosphate, we take that one phosphate, combine it with glucose, and we get glucose 6 phosphate. We get glucose 6 phosphate. Now, this glucose 6 phosphate gets isomerized into fructose 6 phosphate, and again ATP is used to form ADP again. This ADP used here shows that shows the formation of fructose 1,6 bisphosphate. This fructose 1,6 bisphosphate will is still a 6 carbon molecule. So what we're going to do is we're going to break down the 6 carbon molecule into 3 carbon molecules. Okay, so we're going to show this breakdown as 6 carbon molecule into 3 carbon molecules. The first one is known as PGAL. That is your what was it called? Oh, phosphoglyceraldehyde, PGAL. So phosphoglyceraldehyde is PGAL, and the other one that is your dihydroxy acetone, which is basically a trihydroxy acetone phosphate, which is a ketone compound. So dihydroxy acetone phosphate, which is a ketone compound, and it has a functional group as ketone, by the way. And the phosphoglyceraldehyde has the functional group as aldehyde. Now, this now what exactly happens is that NAD plus gets converted into NADH plus H plus enzyme, where this forms as another continuous form, that is your two molecules of triose phosphate, that is your 3-phosphoglyceric acid. So 2 triose phosphate is formed, that is your PGA. What is it? 3 PGA, that is gonna be, or actually 1,3-bis phosphoglyceric acid. Then it forms your two molecules of triosphate, that is your 3-phosphoglyceric acid, that's the normal one. Then it forms 2 into phosphoglyceric acid. Then it forms your PEP, 2 into PEP. That is known as, oh wait, did I forget any? No, no. That is your phosphoenol pyruvic acid. And after the phosphoenol pyruvic acid, we get the other compound. Okay, we get the other compound, PEP. After that, we get pyruvic acid. Congrats, we just got our 3 carbon compound in 2 molecules actually. The one molecule of glucose, we get two molecules of our pyruvic acid. And I think we'll end the stream right now. I'll continue. Okay, I'm not sure whether I'll do it again, but yes, it looks like it's time right now. I gotta revise these steps and I will come back. Bye, bye, guys. Okay.